Hello, my name is Yusuf Khan and I am a researcher at Stanford University. Today I'll be showing you how to recreate this ribosome profile sequencing breakdown, of frame 1, 2, and 3 related to POLG. This video is related specifically to recreating this figure from a manuscript which describes the identification of a novel overlapping reading frame coined ORF-Y in the POLG mRNA, though it can potentially be applied to any other uses you may have. So what you see here in this figure is that for each portion of the mRNA that we're looking at, a portion where we have the open reading, the overlapping open reading frame, we have the portion that doesn't overlap, the portion that does overlap, the main ORF only, and then the entire portion of ORF-Y, and the entire portion of the main CDS. So how did we arrive at this figure? So very simply, I've attached a link in the code, which should be on GitHub. And this takes you directly to the chart on TripsViz. TripsViz is a database where you can access ribosome profiling data. If you want to look at a different sequence, simply enter in your transcript ID right up here. But as you can see, we have ribosome profiling data, which is aggregated for all of the studies listed here. You can choose to select or deselect certain studies based on conditions, which can be seen in View Study Information. For this example, I'm just going to choose all the sequences, all the studies, I should say. Download the CSV file, and I'll call it counts. I already have it downloaded. Place it, and then simply go back to the code. So here, make sure that you put in where and what the name of your file is, and then these are the functions. And here's an important part. So once we run these functions down here, we want to tell the program what portions to map the reads to. So for example, for say the main ORF, the portion that's copied and pasted there is this portion because it's the main ORF. For something that's say the overlap ORF, it's this portion, and so on and so on. So this can be customized for whatever you want. You can simply delete this and type in whatever name and sequence you want, as long as you change it down here in the subsequence dictionary function call. So let's just run this portion as well. And let's look at the ORF-Y only overlap region. And as you can see, we get this readout, which let's compare to the figure. 41 roughly, 16, 13, 16, 13, and then 71. So yes, we're able to recreate the figure, and then simply this is just plotting the result of that program.